Allow me to introduce Mr. Jinju Ong, the Chief Technology Officer and co-founder of Garuda Robotics. He's going to moderate panel one. So Mr. Ong, the floor is yours.
Thank you. All right, good morning, good afternoon, good evening to all of you from around the world. And thank you once again for joining us in this panel discussion. And thank you GSMA and Iskandar for organizing this session. My name is Jinju. I'm the CTO and co-founder of Garuda Robotics, where we have been building basically autonomous drone systems for the past 8 years, and we've adopted cellular-based technologies on our drones for at least 5 of them. Apart from being a system integrator for aviation regulators, telcos, city governments, enterprises, we also produce our own drone products, whether it's drones itself, remote IDs, and various AI business applications. Before I move on, I want to thank our keynote speaker, Barbara, for putting out a framework. I think we had a lot of conversations on this, on how to bridge basically this aviation, drone, and mobile industry. And to make sure that we get everybody kind of to the very concrete, right? Because I think a lot of these things are still at the community level, right? So how do we make it concrete? I would like to screen a video that would hopefully paint a better picture of where cellular connected drones are today. And then we set the context for the discussion for the panel. So let's take a look at not so distant future, like when maybe borders are open again and we all congregate in Iskandar drone and robotic zones. Can we have the video, please?
In the near future, drone companies from around the world will come to Iskandar to train by RPTOs to be licensed RCOC drone pilots and progress to advanced use cases beyond visual line of sight. To test new unmanned aircraft, new flight control technologies, concepts of operations, adopting global standards, and acquiring internationally recognized certifications. Drones in Iskandar will be connected through cellular networks to unmanned traffic management systems, where airspace managers help keep the airspace safe. "3D geospatial data helps drone operators chart out better paths, while 5G cellular technology helps drone operators connect to drones over a wide area quickly and securely. Prosumer drones who can't connect to the network can still benefit by carrying 4G UAV hardware trackers that emits their position to the airspace operator. The airspace around Iskandar will be made safe through virtual geofences that updates stakeholders of breaches. Cellular radio coverage enables detailed monitoring of all aircraft delivering cargo and people across the country. With better coverage towards the seas, drones can use real-time data to avoid other ships when delivering parcels. We hope to see you in Iskandar Drones and Robotics Zone in the near future."
This was a very short clip. Basically, it's a joint clip that we created with One Sky, and I thought it is important because some would say that, especially if you are flying drones today, that you feel that maybe drones are not yet connected to the cellular network. It's not true, right? So we have a lot of use cases today. We're already using the cellular network. We're facing some uphill battle, obviously, and we don't have as many committees as the Europeans and Americans, right? So without further ado, let me introduce you to the panelists for today. Our first panelist today is none other than Mr. Kamarul Asman Mohamad, founder and CEO of Aviation Group from Malaysia. Kamarul is a technopreneur for 25 years experience in digital innovation, communication, strategic development, project management, software engineering, and Aerodyne is currently the world's second largest drone service provider, helping companies with drone technologies, data technologies, and digital transformation. So, Kamarul, if you don't mind, you can give us a quick introduction of yourself and maybe the company, and also how do you deal with all the different regulations and surveillance requirements from different CAs around the world, because you now operate in what 30 countries, right?
Yeah, thanks, Jinju. Right, Aerodyne is almost 7 years old by November this year. Right, we now actually operate in 35 countries. We have offices in 12. Directly to your question, it's actually by having all these local partners. So regulations in America under FAA is very different in Europe to CASA in Australia as well. So we have 2 offices in Australia as well. So each local offices specializes in the regulation in those respective countries as well. So then again, I'll backtrack a little bit about Aerodyne. We call ourselves a DT Cube company. DT1 is actually drone technology. We build our own drone as well, but very often than not, if we were to take the parallel to the aviation industry, we are the airliners. We are not Boeing or Airbuses of the world, but we provide services. Today, we can deploy our drones anywhere in the world within 3 days. Of course, subject to regulatory constraint and all that, but typically we can deploy them within 3 days. Our aspirations is actually to build these capabilities to be able to deploy our drones within 24 hours, anywhere in the world. We are about 500 people right now. We are growing to about 3,000 within the next 2 years. Key solutions that we do, number one is actually critical asset management, critical asset inspections and all that. We also do agriculture. Agriculture is a growing vertical for us. And it's something that I'm very excited about to bring about significant impact to the industry. If I were to look back to look at even the country where I'm orienting from Malaysia today, is a huge industry that is actually now being affected by the pandemic, just because of the labor restrictions. The country lost about 10 billion the last 12 months, really because of the restrictions of foreign labor. So right now, what we are doing is that we're replacing this foreign labor with our drone system. And one of the key requirements that we are looking at right now is how do we really get all of these drones to be really connected. And the way to go is really network connected, GSM connected drones as well. So we have already done some work ourselves, and that's what we'll be discussing later.
So I guess from Malaysia, we connect to the Maxis and Cellcoms. So maybe I'll jump over to the next panelist. Which let me first introduce maybe Peter. Because Peter Jones, he's from basically Telstra, Australia's largest telecommunications company, and he's an expert in drones, UAV, and robotics. He spent the last 4 out of his 30 years in leading the UAV research in Telstra Labs. And in our last conversation, he shared a really cool experiment, and I'll let him tell you a bit more.
Hi everyone. Yeah, my name's Peter Jones. Thanks, Jin. Yeah, I've been looking at connected drones now from the telco perspective for the last 4 or 5 years. Telstra's had drones been in our networks for a little bit longer than that. We're using them to actively inspect all our network towers around Australia and do some other radio planning and design work. In our drone program, we early on looked at what the role for a telecommunications provider is in the drone industry and to see how we could help get this whole industry to really flourish. So we looked at all the different use cases. We know all about agriculture and mining and search and rescue and police and surveillance and military, every possible aspect. But we realized pretty quickly that there's something we need to do first, and that's to enable all these technologies, and that's to sort of get us beyond where regulations are at the moment. In lots of jurisdictions around the world, the really complex high-value operations are prohibited to control risk. And these are operations like flying beyond line of sight, flying autonomously, flying more than one aircraft at a time. All these sorts of things are really high-value operations that are going to really advance the industry and give us all that great promise that all the futurists are predicting of revenue returns on this multi-billion-dollar industry. We need to get beyond this regulatory prohibition place, and we think that telco technologies can provide those alternative safety controls to allow those really high value operations to take place in the future.
Right. So, and we'll definitely come back to each of these technologies in a bit, but let me also just introduce the other speaker we have for today, which is Mr. Chris Kuchera, who is the co-founder and head of strategic partnerships of One Sky Systems from USA. And thanks a lot for doing this, because it's like 2 in the morning for you. Hope you're doing fine. Chris has about 20 years of experience in the aerospace industry and 16 years working in AGI, which is an aerospace software company. And the company he founded, One Sky, is now one of the world's leading unmanned traffic aircraft traffic management systems, helping airspace managers keeping the skies safe and efficient. So maybe Chris, if you can kind of help us understand, right? So the technology you have is going to help companies like Aerodyne and maybe deploy it together with companies like Telstra, right, to help keep the skies safe, right? But why are people not fully using it yet, fully utilizing the kind of the UTMs and the cellular technologies and so on? What's the hesitation here, and what's the current situation on the ground?
Thanks for having me. I appreciate the invite, and don't worry about the time. We're having fun here. I'm in Atlanta. We are doing the AUVSI Exponential Drone Conference. So all of the a lot of the industry leaders are here right now. So it's good. About AGI and sorry, OneSky. Our parent is AGI. We came from a space traffic management type world and have derived a lot of our UTM technologies from that direction. UTM is an interesting technology because it's trying to network drones together in a digital way. And, you know, as Peter was saying, a lot of the regulations, the policy environment for drones hasn't been worked out yet, including the use of UTM. So if you call it a mandate, but, you know, for low-level use of UTM, people need to have something like a mandate. We thought that might be remote ID in the US, and it may be in other countries where you have a network solution where you can see where drones are. But certainly with beyond visual line of sight, we think that UTM would be regulated so that we can have safe, you know, digital airspace pictures and operations.
Yeah. So countries are all more command and control, right? The civil aviation authority says, "Thou shalt follow my rule. This is the remote ID. You should tell me where you are," right? But mandate can sometimes come from customers, right? So if I can maybe kind of circle back to Kamaru, can you share a bit more? Because I think you have the kind of bird's eye view across the world that most of us do not have, right? Which is how many percentage of your customer base, in one way or another, has either implemented or requested for cellular connectivity? So if you can share about what's exactly happening around the world right now.
Well, it's a common request. Dubai Expo is happening very soon as well. I mean, we are deploying our nested system connected through a cellular network, not just for security, but also overseeing the whole experience over there. We have a lot of the requests actually comes to BVLOS requirements rather than cellular. Cellular is actually the means to it. So a lot of activities that we do is actually towards how can we run BVLOS safely and effectively. So in terms of requirement, it's all over the world. I mean, in Latin America, we are doing power line inspection. There's a lot of requests for that. We are doing like thousands of kilometers of power line inspections everywhere and then constantly around the world. Ideally, what we wanted to do is actually flying BVLOS. In some situation, we can get exemption. In some situation, we just have to walk the line. We just do an extended, visual line of sight. We will place spotters and all that. Over closer to home in Malaysia, we are developing the next generation nested drone system with swarm intelligence. And this would require cellular network, 5G preferably, and maybe 6G soon. And the idea here is actually to have this interconnected swarm of drones running the mission by objective rather than piloted by individual. And that's the trend moving forward. I think the trend is really about aerial robots rather than drones that are really piloted. It is still a couple of years away, but I think it's not too early for us to start thinking and planning about this as well. And of course, when you talk about BVLOS, at the end of the day, it's also about UTM. It's all about being aware of where the operations are running. In some countries, the regulations are stricter than the other, even though they are stricter, but there are avenues where you can get exemptions. For example, we have had exemptions in India. We are doing some work in Germany where we are looking at getting exemptions for that work as well. So as an operator, as a solutions provider, this is something that we look at very dearly. and something that we look at to be a reality very soon as well. So that I'm excited to be here.
Do you use Telstra network in Australia?
Yes, we are doing work in Australia right now, quite significantly. One of the largest digital twin project in Australia as well right now. So it's a very exciting time.
Cool. So over to Peter, right? So in the case of, let's say, Kamarogi, if he's going to deploy his nested solution beyond visual line of sight into an Australian landscape, right, where coverage is really hard, right? It's a large continent with a lot of places that's just there's hardly any people, right? So what technologies, other than just like providing bad coverage, right? What other technologies that has the telco put in place? Is it a UTM, or is it something else that can augment the drone ecosystem, right? Because the drone ecosystem itself will not flourish without connectivity.
So, although the coverage doesn't exist, you've got to remember why the coverage is there in the first place. It's there to support the populations. Now, in Australia, the population lives mostly around the coastlines, and that's why the coverage is greatest there. But if mandates come in for things like UTM, and so the regulators and the airspace managers can keep tabs on the drones and steer them around the sky, it's entirely within the capability of the technology to build networks specifically for them. So a lot of our experiments on command and control communications to drones at the moment is focused on narrowband IoT at the lower frequencies at 750 and 650 megahertz in Australia. And that's a network that's an overlay network on our LTE network that extends quite often 100 to 150 kilometers beyond where our towers are. So we can go quite a long way. The other thing we find is that the coverage in the air is a great deal, well, there's a lot more of it than there is on the ground, just simply because you've got that nothing in the way between you and the tower at all. The towers, of course, all the antennas on the towers are pointing down at the ground because most telephones are at an altitude of 2 meters off the ground. But it's a trivial thing for a telco, if we're asked to point some of those antennas upwards and create a new type of coverage at altitude. We've done trials between between Sydney and Canberra. We can comfortably light up jetliners at 30,000 feet. We just got to have good reason to.
Right. But it's like 150 kilometers around the curvature of Earth, right? Because Earth is round. So you have visual line of sight, but it has to kind of the RF has to traverse quite a large distance, even if it's flat or certain terrain. But is there issues on like mountainous terrains and all this coverage? I do know countries where I saw one participant from Bhutan today, I think, right? Like if he's going to get his drones connected through the network, is that going to happen given the technologies that we have today?
Yeah, well, I think it's very application specific too. So when you look at the types of operations that are going to be happening with, say, urban aerial mobility, when we get to air taxis, the largest requirement for data is at the beginning and the end of the flight, when you take off and land, where you need to know the weather information and all the conditions around those launch pads. So, and that's going to be where the people are anyway. So there's going to be lots of connectivity there. Now, for the bits in between the high connectivity areas, there's probably not much else out there to bang into anyway, but that's where we can look at augmentation of those sorts of things. Remember that most of these industrial drones are not going to be flown over the network by real-time operators. They're going to be flown by pre-programmed missions and waypoints and things. So the need to communicate to these things is really exceptional. It's when you need to get them out of the airspace because something else is happening, because there's a fire or there's a police operation or an ambulance operation where you need to clear the airspace. So we look at failovers to other types of communication where we've got partners that are doing long linear asset inspections, we call them, like pipelines, or they've often got their own radio frequency networks that they deploy along the pipelines to augment the LTE networks. And of course, we've got satellite capability to fail over too.
Right. So what I'm hearing from you is that LTE is one way, but 5G, etc. But you can also complement that with satellite, with your own RF network and so on. Right. All right. Let's shift gears a bit, because I think in the introduction slide exchanges now, we guys mentioned about regulation a lot. I think that's been like a big cloud that kind of hovers around our industry a bit, right? So let's turn the attention back to Chris, which I think he spent a lot of time with regulators, right? Just trying to make sure that the systems that we implement helps with the safety and surveillance, right? So I have a very specific question: how do you actually differentiate between the safety goal and surveillance goal, right? So I think this is something that ever since we got involved in the remote ID discussion as well, we realized that everybody wants safety, right? But no one wants to give up privacy. No one wants you to know where they're flying, what they're doing, and yet at the same time, we just like we're on the road with the car, we don't want to bang each other, right? We don't want to be put in jeopardy. We want to be safe. Where the information is, is kind of democratic, right? Everyone has that. But let's say if the police force is flying next to you, the police force is going to tell you that he's actually doing surveillance on you. So there's a lot of these contradictory goals right now that I see in rolling out of UTM, even at the policy level. What is your thought, right? Is it necessary to know who is flying the drone nearby you, and how would you steer clear of them, and what are the strategy that one sky would do for these kind of situations?
Yeah, the safety and security is an interesting balance. And in the US, safety is provided in the air from FAA, and then there's many security agencies that are involved in drone surveillance that want to know who might be flying a drone. So the reasons behind the remote ID is really to remove what we call anonymity, who might be flying the drone, and being able to maybe even target the operator, figure out who they are, where they are, and maybe contact them. Maybe they don't know why that they're not supposed to be flying there. The requirements are different, for safety or surveillance, and I think that's been the challenge, because surveillance has been driving the need for remote ID, and if you have something like the broadcast remote ID, it doesn't impact safety very much, because the range of broadcast remote ID is very short. So unless you're flying very slow, you may not have enough time to move out of the way of the object that you might hit. So what we've ended up with is systems that can track drones that don't really impact safety. With network remote ID, if we're using something like LTE inside a UTM, we can predict much further, because we can see them in the network before they even come up visually, like a sensor can detect them. So the UTM can plan in advance and provide that type of safety. And the other benefit is that you can protect the operators from people that may be looking from a distance that shouldn't be able to see that operation anyways. So the UTM can only allow people that should see the data to have access to the data, whereas something like a broadcast could be seen by anybody, but you have to be in range of the drone. So within the UTM environment, I think you find the right balance for both safety and security purposes that you need for finding safety.
Which also means that everybody has to collaborate and emit their location to what I used to call a benevolent dictator, right? Somebody needs to know.
That's right.
Everything is, right? So,
but I think, with ASTM and the standards work that's been going on there, they've also built in provisions for allowing that, for allowing people to get in there and search regions, to say, I want to see in this region, but then you also have to have the right capabilities, the right passwords to go in and do that.
Right, because if there's no kind of centralization, what was going to happen, and especially like a business like Aerodynes, right? They're going to have a fleet, and there will be no standardization. And like what Cameron opened up just now saying, right? Every local company deals with their own regulators, who have their own requirements to integrate their local UTMs and so on. Maybe Cameron, if you can share a little bit more, right? So has all your local teams been doing extra effort to try to standardize and homogenize across the world the standards for either using cellular or even connecting to UTMs, right? How do you make sure that all the teams are being good citizens in the sky and setting the good examples to all the other room?
Well, there's two sides to these questions that you have right now, right? As far as the regulatory standards, there's only a few in the world. I mean, every country would copy each other and or rather take the best practice from one to another. For example, Malaysia, in the past, we were looking at CASA a lot. The new team are looking at the European standards. The UK CSA and FAA have a lot of influence as well. But if you want to table this out, there's a lot of similarities as well. I mean, everyone is learning from one another based on the best practices, but there are always nuances from region to region and country to country. So as far as the operators, we, the industry players, are concerned, I think what is important for us is actually to be sharing our experiences, how and what is the direction that we should take to, number one, have the right balance between needing to have, the security, the safety aspects, and also to help promote innovation as well. We must allow industry to thrive. We must actually promote this next generation technology. So at least in Malaysia, I can share about this. We have our regulatory sandbox that will allow us to test our BV laws, to do all kinds of operations. And I think the same trend is also happening around the world. In Japan, you have an area dedicated where you can fly. So I think as far as regulators are concerned, I think the general temperature is that everyone is now beginning to realize the importance of the drone technology. I mean, it will have a major significant impact to the economy, to society and all that. I think they are already opening up. This is very different when we first started, 7 years ago. This is something to, something dangerous. I still remember the, 6, 7 years ago when we went to see a regulator. Oh, we're not interested with these toys. We are focused on the, flying vehicle with human lives on it, right? So, but now it's very different. Now the interest is there. Really want to do something about this, and I think industry players must play a role. And just like Chris, as the UTM provider, I mean, we are all playing this role. The industry players are actually sharing ideas and all that. And I think the good news is that I do see that everything is moving in the right direction. It's just a matter of when and how all of us can together. I mean, us having this conversation is actually a step towards that. And I think after this, CM is going to be in this forum as well, right? So I think it's a very, very positive development.
And I'm sure the regulator forum later is going to dive deeper into that. I do want to clarify one thing that just for the benefit of the audience, right? If you look at the rest of the whole world, right, the way airspace is managed right now, I see two different kinds, right? One is very centralized by usually the CAA themselves. And but for some bigger countries, they actually have regional. This is not the FIR, right? This is more like from the ANSP's perspective. They might prioritize the whole airspace navigation service for the ANSPs, and the ANSP then provide a service. They use services for the manned aircraft. Right now they are being looked at and say, can you also provide these services for the drone operators? And knowing the number of drones they're going to have, I think some study by companies like Thales say that in like 10 years time, for every manned aircraft, you're going to have 1 million drones, right? So some number like that. How are the ANSPs going to catch up? And would there be new players being like the drone ANSP, right? The people who would implement and operate the UTM systems, for example, in this case. So question to Peter, and we talked about this because I know that in Australia, the function of ANSP is carried out by this kind of prioritized company, right? Air Services Australia, ASA. Right? How does this work? Do they provide these services as like an ANSP to drones, or does Telstra do that, or how do you collaborate with them, and what's the model like?
Cool. So at the moment, no such service exists in Australia. So we've got really two organisations. So we've got the Civil Aviation Safety Authority. They're the regulator, and they're starting to produce some online platforms that explain to mostly recreational drone operators where they can and can't fly. Really, quite simply, it's a map of airports. Don't fly near the airports. Now, Air Services Australia is the operational arm of the government, and they're the ones that are actually steering the aeroplanes around the sky every day. So they're the air navigation service provider, and that's their job. They've just issued an RFP for a flight information management system, which is going to be really the core information hub of an eventual UTM system that we'll see in Australia. And the way they're doing that is sort of a weird mix of centralisation and decentralisation, where they'll provide the core data services, but allow for third-party UTM providers to access common geographical and weather and flight restriction information from the trusted government authority. So products like OneSky could tap into that and get all the information they need. Now, it might be that a mine site might go with one UTM, another geographical area might go with another UTM, or UTMs might even fall into different types of industry uses. So you might find that surveyors all prefer to use the services that the government offer through their existing mission planning applications, which would, like say drone deploy or Pix4D could also tap into this sort of information.
Right.
So a single centralized source of truth, but perhaps many UTM providers.
Is it free though? Is it like taxpayers pay for, or you buy this, or you're going to buy the data?
Oh, that's that's the question that everybody wishes they had an answer for. So everybody says there's billions of dollars available at the end of this journey, but right now the economics and the business model for providing UTM and aerial connectivity, we don't really know how it's going to work yet. We think that from our telco perspective, we might end up with two different types of services for drones. One very reliable, lower bit rate, command and control and regulatory compliance sort of service on the drone that would probably be paid for by the aviation community, maybe through Air Services Australia or the ANSP or a subscription model. Don't know how that's going to work. And the other type of service we expect to see on the drone is payload services. So those really high speed services for offloading large amounts of data, like video and LiDAR and all those sorts of things. And perhaps that's a service that the telco would sell directly to the operator.
Right. So that's actually very clear, different class of products, which then allows us to then enable everyone to do their PV loss, for example, right? Because you don't need the high-speed data for just controlling your flight from Sydney to Canberra, for example. So given that that kind of setup, I think kind of get back to Chris, right? It's kind of the same question, which is then do we really need this standardization, right? Maybe every country should just go ahead and just implement their ways of providing maybe a basic connectivity tier to all the drones. That all drones are connected in some way or some form with telemetry and C2. That's about it. And if so, can like ACJA or some of the committees that you have been involved in just provide that rather than to wait for like the whole world to study and come up with standards and that's taking a long time. What do you think about that?
Yeah, I mean, those are good questions. I think standards can be created before or after. So you look at something like Google Earth, and did anybody know about the KML file format before Google Earth came out? So that there were a lot of users of Google Earth that drove that as a standard, and it became adopted by the Open Geospatial Consortium. So you can have a lot of users that drive a standard, or you can develop a standard to encourage that technology development, right? And that's what we're trying to do. I mean, with ASTM as one standards body, I think it's certainly important to have the ability to share between USS companies, the service suppliers for UTM, right? So that we can work in both a centralized or federated model. You know, that's how OneSky is architecting our solution. We don't care whether it's a centralized or federated. We want to work in both types of models. When it comes to ACJA, we're certainly looking forward to helping that networks deal with the drone impact. And the issues are really, because you see all those towers, you could be causing lots of interference on the ground, and you could be causing impact to your existing users. One drone may have an impact to many, many people on the ground. And it may be okay in the beginning, but at scale, when you talk about 1 million drones and they're all on LTE, that could cause lots of problems. So in the beginning, you may be able to do a lot right now without making changes to the network. Certainly people know that cell phones work in the air. Just the other day, I was flying with my cell phone in the plane, and I maintained a call for about an hour, and it never dropped. So it was surprising, but so it works. And I also would think that it's happening. You know, we're talking about it as if it's a future thing, but there's people out there that are talking to drones using LTE today. There are companies, I was just here with Verizon yesterday, where they work with Parrot, and they've put a drone, an enabled LTE drone out there for sale. So there's missions we don't have to wait for beyond visual line of sight. Visual line of sight exists, you know, and in the US we have Part 107 commercial operations. You can use drones today to perform your business, and you can use LTE, you know, to do that. So I think the things that ACGA is working out is knowing that at scale, this is going to start causing impact, and we need to think about that and think about how to apply mitigation techniques to the network.
Do you have specific numbers though? Like how bad would the interference be if it's like 1,000 drones per cubic meter, cubic km or something, or 1 million drones for the same volume of space? Is there concrete studies on like how bad interference is going to be, and like what's the maximum number of drones that can be sustained by one tower?
Yeah, I think different networks are studying that, and maybe Peter has a better understanding of that.
That's actually something we're literally testing today. My colleagues are out flying these sorts of missions today, doing the analysis. So what ACGA has, the approach ACGA is taking to ratify LTE sign-off by aviation, really there's 3 requirements. We need certified devices, which is, so we know the performance of the device. We need an aerial profile in the network, which we heard Barbara talk about, and we need to be able to publish the information around connectivity at altitude. Now, the aerial profile in the network, some of the features of this are specifically there to minimize the interference caused by the drone. So this is what we've been testing today in regional Victoria. We've got a mechanism in this aerial profile that allows the network itself to control the transmit power of the modem on the aircraft. So on the ground, the modem is transmitting at its highest powers, but as the drone gets higher and higher, the drone power actually gets lower and lower, so that it minimizes the interference, and it's only got just enough power to get to the tower it's talking to. And we'll see mechanisms like this emerging through ACGA and the GSMA standards to allow these very specific profiles for aerial drones in the first instance, but then air taxis and the passengers in the air taxis, who of course want to use their mobile devices while they're flying over our heads.
Right. So to test that, okay, so I understand the part about doing the test, but to get to the point where you can deploy this and get it properly certified, do you think this is something that we will go to Telstra for, or we'll go to the ACGA for, or some global standards body or certification body, or is that still kind of within the own country's cellular network, the spectrum manager of the country, right? So for Malaysia's case is MCMC, the Multimedia Commission.
Yeah. So it's everybody. So what ACGA is doing is basically translating between telecommunications industry and the aviation industry. And once we can talk the same language, then the aviation industry will be able to say, in order for you to fly safely, you need a network with these characteristics and these metrics. So you must have more than 2 cell towers in sight at any given time. You must have this amount of throughput. You must have this receive power level, whatever their specific requirements are. But at the moment, they can't tell us them because we don't speak the same language. So first thing ACGA doing is getting that common framework up. And then once we can talk the same language, then they can give us the specific numbers we need to hit. And then we can start publishing the airspace routes that will meet those parameters for people to fly through. Or people can request from us a route from A to B that hits these particular RTCA standards, and we can give them a route that will hit those metrics.
Right. So that's a very important point. The telco is not going to reinvent so much of the infrastructure. This is already there, but just to pre-qualify a subset of the infrastructure that meets a certain standards and say these are green zones for your BVLOS, these might be yellow zones, this might be red zones.
So the aviation regulators will have performance standards. And once they know what they are, we've now got a framework so they can tell us what we need to hit, and we can tell the operators how to achieve that.
Right. So I'm bringing up one of the questions that's coming in the chat. So I'm going to start mixing in some of the questions I'm seeing from the audience. And audience, if you have any questions, please put them in the chat. So it's kind of related, which is this person called us IZ Zukari. He's asking how would drones be operated, whether it's through Wi-Fi, private LTE, public LTE, and so on. So far, we have been talking about public LTE. do you see the potential of connecting to a private LTE? Is that necessary to have a separate spectrum, but it's under the LTE technology, if not the 5G technology? And would Wi-Fi do? Would ISN-based, unlicensed bands, would it be able to fill in the gap?
Well, yeah, the short answer is all of those, and it's really dependent on the application. The Parrot 4G drone that Chris was talking about before, that flies on a Wi-Fi connection until it loses connection, and then it changes over to a 4G connection. Most of the consumer market drones, most of the consumer drones in the market now are talking on Wi-Fi frequencies of the ISM band. But of course, we can have drones that fly in any mix of them, or any one of those technologies on its own right.
Right. Chris and Kamara, anything to add to that question? Do you use it by any chance?
Yeah, I think it's part of the strategy for how you're performing your concept of operations, your mission. So, close into your landing area, right, where you're coming in for takeoff and landing. If you think about larger vehicles, right, air taxis or something like that, you might have more a need for a private, maybe something that's more controllable at that location. So it could be a point to point, and then as you get up into the air and you're transversing long distances, you might have something more like LTE. So could be a mix. And then if you want failover, if you want something that if things break down, maybe satellite is a good thing to have on board for redundancy. So I see the mix of technologies.
Right. Yeah, maybe I can just add to that as well. I mean, we have worked on several projects where it is actually a mix. So it runs on private network to connect from repeater stations, for example, for the PV loss type of operation. And where possible, then we hop into available 4G at that stage. Right. And then switch over to network again. So we would have repeater stations. So I think basically what the industry is doing is trying to make do with what we have at the moment. And once the coverage are widespread, then yeah, we would want to have 5G throughout the
the question directed to you, Cameron, is more of like, do you as a drone company now have to be like a network integrator as well? Or should this be kind of like part of the network offering by the network companies and telcos?
Well, I mean, I view ourselves as a solutions provider. So we would have to pick and choose what's the best technology available out there. I mean, of course, ideally, if we can just hop in and use on the available 5G network, that would be the easiest. But if you have, for example, a very unique requirements where we need to, say, monitor a pipeline of a few hundred kilometers in a remote area, you will not have connectivities in those areas where there's no habitable, it's not an habitable area. So you have to make do with what you have. You have to be creative. You can use satellite, so you would evaluate what is the cost of satellite usage, or you can use repeater station, or you can actually wire the 100 kilometers. It could even be cheaper as well over time. So you just have to be creative. So as an operator, our philosophy is to really find the best solutions for our customer. So very often than not, we would find the commercial side of it will have a significant influence on the strategy that has been taken.
Chris, you want to say something just now?
I was just going to say, with the LTE, right, you were talking about public or private, and I was thinking about the network slicing kind of aspect of the network, where you can carve off channels that say this is only for aviation, where others might be only for the ground. And that might be one way to mitigate interference, aside from things like the LTE aerial profile. And I think Peter might have some experience with that too.
Yeah, I think the aviation regulators too will have some very strict security requirements around the connectivity too. So we'll see private APNs and dedicated bandwidth specifically for these the regulatory compliance side of things.
So for the benefit of the audience, right? So network slicing is something I think the 5G standard specification is standard. So once the telco rolls out 5G, there would probably be products around network slicing where you would own the entire band frequency. You basically have priority over everyone else, like consumer network or like YouTube Live, Facebook Live, as well. As long as you have that connectivity, then at least you can use that to operate your BBLOS operations. But once you fly past and you leave the tower, the radio frequency around the tower gets given back to the pool of shared frequencies. So, but it's just, I guess I really want to get to the bottom of this, right? So I want to find out what is the thoughts around standardization in this case, right? Because on one hand, we have a lot of ways to connect to the drones, right? We have 5G, 4G, we have Wi-Fi, we can sometimes use satellite. ACJ's work has been to bridge it to the operator, but the operator often wants to push the license band that they already invested in and therefore want to monetize, right? So how are we going to put all these things together, right? I do know that my interactions with Singapore's case, Singtel is also trying to bring in some form of Wi-Fi products. So the Wi-Fi and the 5G kind of merge together. But we are no closer in covering, say, maritime environment, right? So we have an opposite problem, not the 100-kilometer pipelines. Our problem is to fly 50 kilometers into the sea and have connectivity there that's not satellite comms, which is very limited in bandwidth, right? So that's the kind of situation where we are in, and how is either the standards committee or the telco coming in to solve a problem like this? But what would be the recommendation?
Oh, it becomes more of a commercial problem than a technology problem, unfortunately. I think we've got the technology to solve the problems, but not perhaps the commercial incentive to do so. So it's a little bit chicken and egg. Once the drone operations get to scale, there'll be a clear market there for the services. But until they do, there's no money to pay for the building of that infrastructure. So I think we've got to rely on governments to a certain extent to be a little bit forward thinking and allow these investments to sort of kickstart and allow this critical infrastructure for the aviation community to really get established. So it's a bit of a hump to get over initially, but with a little bit of clever planning from our governments, I think we'll get there.
I think one of the questions was about standards. What is coming out of ACJ, I guess, as a standard that we should be focusing on. And I think some of these things are mitigating problems that networks might have in the future when you see volume. But certainly with aviation, you have an issue with certification of devices. So if you have avionics on board that are doing command and control, making sure that those are certified is important. And so the work that we're doing
Akunya dah rambung betul-betul. Let's
mute maybe.
Dalam bag.
Somebody is unmute. Okay, go ahead.
Okay. Yeah, no, I was just saying that certified capability, and how do you certify that? That requires working with the regulator, right? And they call those TSO. I don't know if that's a global word, but TSO devices. So you can get your drone certified with a modem, or you can get your drone certified and then add a TSO modem later. But that thing has to be certified to be able to add it to a drone after the drone is certified. So that's what we're helping with, is trying to make sure that that's something that we can do.
Can you share some of the parties who are doing these certifications, and would they be interested to come to Iskandar to perform these certifications?
Oh, I mean, well, the certification in the US is the FAA. So they're the ones that are saying things that are airworthy. And they allow companies that are working. So if you're a company and you're building a drone, then you have some ability to go out and pick capabilities to put on your drone at a later time. And so that's where you go out and you choose different types of avionics that might be certified to put on your drone. So if you're building something, I guess you have to work with the regulator in your country to get that done.
Yeah, as a telco, we certify devices to operate on our network all the time. Things like this little M2M modem here, which you can't see. It's something that goes through our labs and gets certified for use on our networks, because we need the assurance that it's actually going to do the job it says it does. In the case of handsets, we need to know that they're going to, at the very least, make emergency calls. So with the harmonisation of standards between telco and aviation, it's going to make that handover of these certified devices on our network into the aviation sector a lot easier. We've already got some modems that cross domains, and we see those deployed in things like our police helicopters.
Right.
It's still a little bit of a grey area for both industries.
Right. So yeah, because we're going to have air taxis, we're not sure we're going to have helicopters or drones in the future. All right. Any other? I'm going to go through more of the questions from the audience. Some of them are becoming quite interesting. If anyone wants to take the latest one, right? And if they're in progress for connecting and controlling underwater drones, right? Does 5G go underwater, or like the cellular?
No, I can confirm that 4G does not work underwater, and there's a really funny story behind that, and a very expensive, very wet modem now. But no, radio frequency stuff definitely is not the answer underwater.
Right, but we'll find another way to control them by, I don't know, having a buoy or something, right? So
yeah, look, there's some interesting PhD stuff. Telstra does have a little submarine, and we've got a GPS system in that submarine that was a PhD student's work. And that works by having LTE connectivity on a box on the surface of the water, on a boat or something, or on the end of the pier. And then it transmits to the drone, to the submarine underwater using a sort of sonar technology.
yeah. All right, so I'm going to go to one of my kind of general questions. This is more for each of you to share if you have one. I'm just open to the floor as well. The question is like, share us one story that having a cellular connected drone has added value to your customer, right? In any way, that especially if this is not what we think of not naturally, right? Does anyone want to go first on this?
Yeah, I can talk a bit. I mentioned about it earlier as well. Dubai Expo is starting very soon. It was supposed to be Dubai Expo 2020. We have been engaged to do the monitoring of the safety, the traffic management and all that using cellular connected drones. And these drones are nested and on location as well. So the team is actually doing installation now because it's the Dubai Expo 2020 is only happening in September 2021, right? So yeah, so it is happening and it's actually adding real value because we are talking about having real-time detections on the drone. So we use AI, we use CV on the drones itself as well, and then the technology of where the drones are actually moving from nest to nest, providing good visibility and also to response to any emergency situation. So it is currently being tested over there. So to me, that's the most exciting thing when it comes to cellular connected drones that we are working on right now. We also have a situation before where we had to fly beyond visual line of sight. Because we need to the 2.4 radio frequency between the controller and the drones would not work because we have to climb over a tall hills. Well, it's either a mountain or hills, but it's a very tall hill, and then go down and inspect and assess at the other side of the hill as well. So luckily, we were able to verify that the cellular connection actually works. The alternative to our work is that it would take about 1 hour of work to go around the island in order to do that. So the fact that we are able to fly our drones, climb the hills and go down and do the work that's needed, we can get it done within half an hour instead of 24 hours and wait for the tide to come out and down using a boat and then go and do the inspection. So it's a real, it was a proof of concept, but it actually proves that using drones, if you have the right connectivity, it will have a major impact in terms of operations for our customers. So in the past, it will take them that kind of time in order to do this. So we have proven it that it's possible.
Right. So in summary, productivity is basically cellular technology translates to productivity for drone service providers. How about Peter or Chris? If you have any stories that cellular has made a difference?
Yeah. So in Australia, there's a Google or Alphabet company called Wing doing logistics trials, deliveries with drones to a couple of suburbs in Canberra and Brisbane at the moment. They're doing short-range deliveries of some small consumer goods, like some pharmaceutical stuff, and I think coffees and some fast food. And they're carrying modems and using SIM cards on our network. Now, that's part of their safety case to the regulator to allow them to fly at all. But I think perhaps the biggest benefit they're getting from that is the large amount of data they're gathering on each and every one of those flights that feed back into the regulator and progressively let them back off the sort of constraints that the regulator requires of them. Initially, when they first flew, they had to have people watching every part of the flight. I think at one stage they had 16 spotters around the place just watching these things fly from end to end. And as the regulators got more and more confidence through the gathering of the data, they've been allowed to fly that now as a BV loss mission, so they don't need to see the destination and the launch and every little bit of the flight in between anymore. So I think data gathering has probably been the biggest benefit to that customer.
So cellular is important because it is data that goes straight to the central source rather than just go to the GCS and it's kind of lost with the drone operator. And we now have a drone agnostic, operator agnostic pool of data to improve the infrastructure that we can then turn it back and offer it back to the drone operators. And maybe the last one, Chris, is you have any stories you want to share?
Yeah, I'm thinking of two places where we were using LTE. Unfortunately, in the US, the trials that we are doing, they don't largely use LTE. They're using other open frequencies and point-to-point systems when they do their testing. So we don't get to use LTE too much. But in international, I think the first UTM trial that was ever done, I think internationally with multiple UTM participants was in Australia, and it was with Telstra. And so that was the first work that we did was actually with Peter. So that was pretty neat. And then moving beyond that, our work in Singapore, and what was very interesting there working with M1 was trying to study the network in a very urban environment and where you have a lot of capability, a lot of service, but trying to still understand how the urban structures can cause blockages and how do you predict where the drone can fly safely. And so it was a massive amount of data collection where we flew many, many flights to study the network. And then we learned a lot about how to predict the network capability at altitude. So some of the existing technologies to predict network coverage don't really study the network at altitude. So we're learning about how do you open up your eyes to where the network can provide, coverage at altitude. But those flights were interesting in allowing us to see how the network behaves, at altitude.
Right. So which means that, I mean, in summary, kind of like given cellular networks, there's a whole new dimension that there's not fully explored yet, even though we have a complete UTM system. If the UTM can be properly complemented with a good cellular technology, there might be more use cases and more data that will allow us to design safer airspace usage.
Yeah. And we kind of glossed over that. Maybe you talked about it before I got on, but the benefit to aviation is that the traditional air traffic management infrastructure was built for aircraft flying at a higher altitude. And so we have communication systems set up, but they're mostly voice communications and they're dedicated. We have GPS, but GPS has no blockages at 3,000 feet, so you don't need things like RTK or mitigation solutions. And certainly surveillance is easier because you have radar and radar coverage. So it's easier because we have the technology and infrastructure and ATM. And at lower altitudes, that's why we really need the LTE infrastructure to provide the communication, navigation, surveillance infrastructure. And maybe beyond that, we might see weather sensors on board towers that are providing weather information at a lower level, right? Or RTK solutions for GPS mitigation.
So CNS, the basics of all air navigation service provider, now possible through cellular networks. And with that, I'll close this panel, and thanks a lot for all three panelists for sharing your insights. Back to you, Christian.